Hello everyone. This will be your final video for your Unit 2 Linear Equations section. Notice over here, fitting linear models to data. I'll cover this section, so it's the last topic before your Unit 2 Linear Equations exam is due, which getting on this very soon is good because you have more assignments due coming up the very next week. All right? So, let's look at this. Up to this point, we have modeled linear processes by using only 2 points, or the slope and y-intercept. This gives us one unique linear equation. However, in the real world, that doesn't happen very often. You know, sometimes we have a lot of data points that can be modeled by a line, but they aren't exactly equal. So here's an example. Here's some data that shows the median age of U.S. residents since 1970. The median age is the age of the person that's exactly in the middle of the population. So if there's 300 million people that live in the U.S., there's 150 million people that are older and 150 million people that are younger. That's what median means. It's pretty close to the average, but not exactly. So notice that our median age is increasing, which means there's more and more people that are over this age. That's contributed to by the baby boomers. But if I was to pick, say, this point and create a line, it would create a different line than if I picked, you know, the equation would be different than if I picked this point and this point. Maybe what if I picked this point and this point? All of them would produce a different equation of the line. So which equation of a line would be the best? Well, that's what Excel helps us do. It helps us create a line of best fit. So first, let's just graph these data points. So down here, I'm going to let this be. Now, we always like to start off with our first year to be year 0. That way this number can be our y-intercept. So we're going to let year 0 be 1970. So this is going to be years since 1970. Years since 1970. And we like that to be year 0 because that helps our algebra to work out. And then over here is the median age. All right. So picking a useful scale, since our numbers are 28, 30, 32, I'm going to let each line represent 5 years. So 5, 10, 15, 20, 25, 30. So 28 is about right there. So there's 28. So there's our first data point, 0, 28. Now let's look at our next data point. So 10. So each line represents 5. So this one's 10. This one's 20. This one's 30. So 10 represents 30. So 30 is right here on that line. So that's right here. Then 20 was at 32.8, so a little bit more than that. Then 30 was at 35.3, so it's a little bit more than that. So they look like they're on the same line, but they aren't exactly. So what equation of the line, what y equals something, is going to be the best fit? Because no line's going to be able to go through all these points because they're not in a straight line. But we can pick a line that's as close as possible to each point. That's what Excel does for us. It helps us pick a line of best fit. All right? And the reason the line's nice is because I can go out and predict, well, in 2020, what's the median age going to be? Now, of course, this line is not going to increase forever because the median age is not going to go off to 100. So there is going to be some point where this thing starts to curve back according to the data, but later on we'll have to worry about that. We only care about the data in this section. So let me show you how to create a scatter plot in Excel. Let's use these data points. So what you need to do is come in and open up Excel. If you don't have Excel, you can get it through Microsoft or through OpenOffice. Apache OpenOffice has an Excel program that you can even save your files in a .xls format. So these are the points I'm putting in. 0, 10, 20. So all I'm going to simply do is type in my data points. 0, 10, 20, 30, and 38. Over here, I'm going to type in 28, enter, 30, enter, 32.8, 35.3, 36.8. So that's the first step. Then what you do is you highlight your two columns. You go to Insert, Scatter, right here, Scatter only with markers. So we only want to scatter with markers. Then you need to come down and choose Layout 9. What Layout 9 does is it produces our equation of best fit. So let's delete that off. Make sure you always put in axis titles and your chart title. All right, so this one will be median age of U.S. residents. So I need to be able to just look at this chart and tell what data it's given me. Axis title, this is years since 1970. And over here is the median age. So this axis is the median age, down here is years since 1970. So here's the graph of that line. Notice that the y-intercept is not exactly 28 like it would have been from our data point, 0, 28. And the slope is 0.2389. So let's think about that in a rise over run type of thing. So here, use a linear model to predict. So we didn't worry, we didn't make a linear model from 2 of the data points. I didn't care about that. Enter data into the Excel worksheet. How do you insert a scatter plot? You go to Insert. Well, you highlight the columns. You type in and highlight the columns. Then you go to Insert, Scatter. And then you choose Layout 9. How do you change the titles on your graph? By clicking on them. Use Excel to fit a regression line, best linear fit using squared error to the data. Layout 9 creates the regression line for us. What is the linear regression equation? It's 0.2389x plus 27.897. What is the R-squared value? That's this number here, 0.9963. And I'll talk about what this means on the next slide. So here is the equation of our line. So what this means is you give me a year after 1970 and I can estimate the median age of U.S. residents. Notice how the line doesn't go through this data point. It doesn't even go quite through this data point because the y-intercept of the line is 27.897 and this data point is 0, 28. But what it does tell me is it gives me the slope. So slope is rise over run. So it's age over years, right? Rise over run. Rise, my y-axis is age over years. So it's 0.2389 over 1. So what it means is the median age goes up by 0.2 of a year every year. So basically our median age is getting bigger as time goes on because people are getting older in our society. That's what the slope means. This is the slope of our graph. So every year that goes by, the median age increases by 0.2389. Now here's what the R-squared values predict. R-squared is a measure of how good, of the goodness of fit. The closer to 1 it is, the better. So notice here how it's R-squared equal to 1. All the points are on the line. This is an excellent fit. 0.83, this is a pretty good fit. 0.18 is a extremely poor fit. See how far the data points are from the line? Now, a good, part or a good rule of thumb for a good value is r squared needs to be greater than or equal to 0.8 to be good. So we always want r squared to be greater than 0.8. If it's greater than 0.8, we probably have a pretty good fit. If it's less than 0.8, we don't have a very good fit. What does the linear fit tell us? It's good, right? This is very good, 0.9963. It's very good. Use the best fit model to estimate the median age of the U.S. population in 1992. So remember, this is years since 1970. So x equals 22 because it's years since 1970. So that's about right here. So looking at the line, it should be around 33 years old. Let's plug it in. Y equals 0.2389. Whoa. Times 22 plus 27.897. Let's go back to our calculator. 0.2389 times 22 plus 27.897. So 33.2 we'll call it, which is exactly what I thought it would be from the graph. Now let's look at it. It says use the best fit model to predict the year which the median age will be 40. So it wants to say when y is 40, what is x? Notice it's going to be way out in here, right, by looking at our graph. Looks like it's going to be way over here, so it's going to be like 50 years after 1970. So about 2020 is what we're guessing. Well, let's set this equation equal to 40. 0.2389x plus 27.897. Let's subtract 27.897. So let's go to our calculator. 40 minus 27.897 equals 12.103, and then I'm going to divide it by 0.2389. So x equals 50.7. What does that mean? That means years since 1970. So I need to do 50.7 plus 1970. So that means approximately 2020. All right? So in 2020, the median age would be 50.7 according to this. Now what I want to do here is show you, I just want to create this graph one more time in Excel. Because this one has a few more dots, I just want to show you how to do it one more time. Let's go back over here. So what I'm going to do is I'm just going to delete this graph off and delete off all these data points and start right here. So I'm going to type in these numbers right here. Right? You always start at year 0. So 0 through 9. So 0, 1. Now if you do a step size, if I do two numbers like that and highlight both of them, then grab this bottom right corner, it increments out by whatever the difference was of these two numbers. And now over here I'm typing in internet users in millions. We have 495, 677, 785, 914, 1036, 1159, 1393, 1611, 1858, and 2084. So here's how we do a scatter plot. Grab both lines, go to Insert, Scatter, Layout, 9. Now look at these points. They're not exactly on a straight line. So chart layouts, layout, 9. This one has the f of x. That tells you it's going to give you your Excel average rate of change. I like to click in the middle and get rid of those lines. I like to get rid of that. I like to pull this down right here where we can see it. Kind of like that. Let's put an axis title here. So this is years since 2001. This is internet. Here I'll call this users in millions. Make sure you put your unit, because this is not 500, this is 500 million. And I'll call this global internet usage is the title of my graph. I mean, you can pick a few different names, but really, I need to be able to extract all this data just by looking at this chart. This chart tells me everything, this graph right here. So here is my equation, y equals 171.26 plus 430.53. Calculate the average rate of change using Excel. Remember, rate of change means slope. Okay? So let's go right here. What do the average rate of change suggest? So my m, my slope, is 171.26, which implies, what am I doing? I'm doing users per year. So users per year. So what this number represents is 171 million users per year. So the internet gains 171 million more users every year since 2001. And in the year 2001, it had 430 million. Notice how our Excel regression line does not give me the same point as in year 2001. In 2001, there were actually 495 million, but what the graph would tell me is 430. So it's underestimating. And that's because it's the best fit line. It's not the exact equal line. There isn't a line that can go through all these data points. All right. So you can go through and answer these questions. What does the graph tell you about the average growth of internet usage? It was approximately linear, right? Is the linear fit good enough to use for estimation? Yes, it is, because it's greater than 0.8. All right, and then here's another one. So you could graph another one, put in this column, here's your X, and this column would be your Y. Okay? So this fitting linear models to data is due 6/27 by midnight. And I'm going to pull the assignment up and show you exactly what I want you to do. Now, the assignment, let me go ahead and click on it. Here it is. It has two problems. So it has two of those linear fitting questions that I want you to fill out. So here's the first question. Here's your data points. So here's your X's, resting versus maximum. So you're comparing resting heart rate versus maximum heart rate. Put these 5 data points in Excel down this column, right? And then put your maximum heart rate down this column. Create a scatter plot. Use layout 9. Choose the correct Excel regression line. Is it a good fit? This wants R, not R squared. So you need to take this R squared value and square root it. We need to solve this for R. So take the square root of 0.9782. That's what this value wants. And then what I want you to do, answer these questions. You have to answer all these blanks. And for the by hand portion, basically what I want is this turned in, but applicable to your questions. So I want one sheet to be resting versus maximum heart rate, and then you can click on another sheet and put in the second problem, which is year versus billions of dollars. So philanthropy. So this is money given away. So remember, year, I want this to be year 0, year 1, year 2, year 3, right? So if I was doing this problem, over here I would type in 0, 1, 2, 3, 4, and 4, right? That's the last one. And then type in 227, 230, 232, 235, 235. And it's in billions, and then create your scatter plot. Insert scatter. And make sure that you label everything, okay? So that's it. And then this file, just have your 2 problems on the 2 sheets, save the file, the Excel file, and email it to me. All right? So that's what I want you to do for that. So you have 2 by hand things to turn in. All right? You have, from your mixture problems, you have those 3 applications to do in Microsoft Word. So you have these 3 problems to do, 3 of these 5, and you have those 2 Excel graphs to turn into me. All of this is due by 6/27 at midnight, so that you can do your linear equations exam 6/29 by midnight. All right, this was the final video for Unit 2. Let me know if you have any questions about how to submit assignments. I'm perfectly fine with you typing them into Word and Excel and emailing them to me. That's probably the most convenient way for you. That's fine with me. I just want you to do the work. All right? So let me know if you have any other questions. Thank you and have a wonderful day.